the output bin can be moved in this plane of motion. In fact, there are 3 independent inputs, so all the 3 motions, that is 2 translation and the rotation of this output bin, can be independently controlled. As we might notice that if this hydraulic cylinder is moved, not much change in the orientation of the bin is taking place. Same is true even for this actuator, whereas the third actuator is mainly changing the orientation of the bin without causing much change in its location. Sometimes certain kinematic pairs can be disguised due to certain practical considerations. As an example, let us look at this model of a punching press. Driven by this eccentric. Here, the eccentric is connected to the motor shaft eccentrically, and this is the connecting rod which is driven by the eccentric, and the punching tool is connected to the connecting rod. The continuous rotation of the motor is converted into to and fro oscillation of the punching tool. It is very obvious that the punching tool has a prismatic pair with the frame of the press. There is a revolute pair between the punching tool and the connecting rod. There is a revolute pair between this eccentric and the crankshaft. But what is the kinematic pair between the connecting rod and this eccentric? This through a model. This is the model of that Scotch-Yoke mechanism. This is link number 2, that is the crank, which has a revolute pair with the fixed link at this point. Another revolute pair between link 2, that is the crank, and this block is here. This block, link number 3, has a prismatic pair in the vertical direction with link number 4. And link number 4 has a horizontal prismatic pair with link number 1. Now, if we rotate link number 2 at a constant angular speed, as we see, the red link, that is link number 4, is performing simple harmonic. I will now show this through a model. This is the model of Oldham's coupling. As we see, the rotation of this shaft is converted into the rotation of this shaft at the same speed through this intermediate member, which has a prismatic pair here and a prismatic pair at the top. So there are 2 prismatic pairs at 90 degrees to each other. This intermediate member moves in and out in this prismatic pair and also at this prismatic pair. Of course, this coupling is good enough to transmit power only when the offset between these 2 shafts is not very large, because lot of power is wasted in friction at these 2 prismatic pairs. This is the model of the elliptic trammel. As we see, there are 2 perpendicular slots in this fixed link, and this is that rod AB, which has revolute pair with this block here and with this block here, and these 2 blocks move along these 2 prismatic pairs. Now, if we move this rod, as we can see, this particular point of this rod generates the ellipse which has been drawn with the green line. Now, if we consider the midpoint of these 2 revolute pairs, then as we see, as this rod moves, this particular midpoint generates this red circle, as mentioned earlier. Model where we have a higher pair mechanism, and this link 2 and link 3 is having a higher pair at this point. The center of curvature for this body 2 at this point of contact is here at C2. Similarly, the center of curvature of this surface of body 3 is at this point C3. Now, as we said earlier, we can have an equivalent lower pair linkage by having a revolute pair at C2 and another at C3 and connected by an additional rigid link. So thus we have a 4R mechanism which is instantaneously equivalent to the original higher pair mechanism. I have connected these two bodies, that is this red link and the original link number 2, rigidly. And as we shall see that where I can move this mechanism, the same motion is transmitted at least around this contact region between body 2 and body 3, whether it is through the higher pair mechanism or through this equivalent lower pair linkage. To distinguish the movement of this body 3 in the lower pair linkage and this body 3 in the higher pair mechanism, let us notice at these two lines there is a red line on this body and there is a blue line on this body. Now around this point, as we see, these two lines move almost the same way because the velocity and acceleration relationship between the original higher pair mechanism and the equivalent lower pair linkage is just the same. But however, when there is a lot of movement, these two lines separate out. This blue line and this red line are not same anymore. But around this point, it is only here that these two lines separate out because the centers of curvature is very different from what it was at this configuration. So this is what we mean by instantaneously equivalent lower pair linkage. We can show another model with one surface flat, that is the radius of curvature is infinity, and the other curvature is a circle, that is radius of curvature is constant. Under such a situation, of course, the equivalence will hold good for the entire cycle of motion. The higher pair mechanism between link number 1, 2 and 3, and the center of curvature of body 2 at the contact point is here, whereas body 3 has a flat or straight contacting surface. Consequently, the extra link that is having here gets a prismatic pair between body 3 and that extra link, and a revolute pair between body 2 and that extra link. If we connect these lower pair linkage, link number 2, with the link number 2 of the original higher pair mechanism rigidly, then we can see that same motion is transmitted by both the lower pair linkage and the higher pair mechanism. So let me now